Now I want you to show that something is a 0. I'm telling you this guy is a 0. I want you to prove it to me. I want you to show me that this is a 0. And how will you go about doing that?
To get it to a quadratic next square, so we're going to factor out.
How can you show that a number is a 0 for a function? I have to do some division. Do that synthetic division, right? Now we got to be careful when we set this up. I'm going to be using synthetic division where my k value is complex, right? Fun stuff. Just check it out. Check it out. What will you tell you that this guy actually is a 0? What are you going to be looking for?
0 remainder.
A remainder of 0. So in this box over here, we should have a 0. So my k value is here. X to the third, x squared, x, and my constant. So what's my k value? Negative 2 plus 3i. What's your x to the third? 310, 31, and negative 26. Do y'all agree? What are you going to do first? Bring down the 3. Then what do you do? When I multiply these, what do I have? You go slowly here. I get negative 6 plus 9i. Now notice how I'm lining this up. I'm going to line it up in the appropriate columns. Now just so we don't have people hooking up with other people, I'm just going to draw a little dashed line here so I can separate these pieces from each other so they don't get together. So what's 10 minus 6 plus 9i?
4.
What's your signs? 4 plus 9i. Do y'all agree? Now we've got to multiply these guys together.
That's just wrong. How can this be easy?
Well, tell you what, why don't you plug negative 2 plus 3i into this guy and cube it?
No,
You want to complain?
Creepy eyes.
You've seen nothing. You know nothing of creepy eyes.
You have more to give, really?
Multiply this. FOIL, right?
Negative 8 minus 18.
Tell you what, let's do the real stuff.
12i.
That's negative 8. 3i plus 9i gives you what?
18 minus 18 plus 27 squared.
You're multiplying here. That's 27i squared, which becomes negative 27.
I was going to ask you if we do the negative right then and there before we bring it up. Yes?
So is
We
it
don't
gonna
write
be
it. We don't bring it up as I
27?
squared.
No, I don't. I can't even. Can you even? This is real. Is this real? So I'm going to go up here to the side and work that out for you. So negative 2 plus 3i. 4 plus. Oh, now you're going to give me an answer, huh? I'm going to use a pen so I can write more clearly here. This gives me negative 8 minus 18i plus 12i. 3i times 9i is 27i squared, so it becomes a negative 27. So what is all of that?
Minus 6i.
It's negative 35 first, right?
Negative 35 minus 6i.
Negative 35 minus 6i. So add these and what do you get?
We're getting negative 35. Negative 4.
Negative 4 minus 6i. Sorry, I have to squeeze that in there. So now I have to do negative 2 plus 3i times negative 4 minus 6i. I get 8 plus 12i minus 12i. Oh, that's nice. Positive 3i times negative 6i is negative 18i squared. What does negative 18i squared become?
18 plus 8.
So what is all of that? 26? And the i's cancel, right? So what's my remainder? 0. What was it supposed to be? 0. I told you it was 0, right? If you don't get 0, then guess what?
Wrong.
You're wrong, or I'm wrong. I can't even do that. Can't even keep a straight face.
It happens. It's okay.
Don't do that. Not today. Now I asked you to find all of the zeros, right? How many am I missing? I am missing 2. But here's something I want you guys to know about complex zeros. Notice how this guy is a complex number, right? And he gives me a 0. Complex zeros occur in conjugate pairs. Write it down. Complex zeros occur in conjugate pairs. Find a good marker for that. Complex zeros occur in conjugate pairs. Okay, that means that if x equals a plus bi is a 0, then what?
2 minus 3 would be a 0 as well.
Then x equals a minus bi is another 0. So we're saying here that negative 2 plus 3i is a 0. So what is its complex conjugate? No.
Negative 2.
Complex conjugates, the real part stays the same. It's the imaginary part that has a different sign. See, look, a plus bi, a minus bi. It's still the same real part, right? So let's do more synthetic division. Now notice that we already broke the polynomial down to something a little bit smaller, right?
But there's supposed to be 3 for that one, right? But we're only...
How many do I have right now?
2.
I've got 1, and I'm going to verify that the complex conjugate is also 1. So what's the complex conjugate?
Negative 2 minus 3i.
All right.
That's 2.
Let's see what happens here. Now, I'm not going to plug it. I'm not going to use these same coefficients up here. Notice that you went from that was something that was x to the third to something that was x squared now, right? You already made the polynomial smaller, so keep it smaller. X squared, x, and constant. So you've got 3 from here. 4 plus 9i.
Well, isn't that quadratic? So can't we just...
It's quadratic with complex coefficients.
Okay.
So don't touch it with its complex coefficients. So just trust me. You won't like it. You don't like plugging in fractions into the quadratic formula. You're not going to like plugging in complex numbers to the quadratic formula. So bring down the 3. And what happens when you multiply this? What do you get? When you combine, what do you get? Multiply, what do you have? 4. So what's your remainder? Now, since this guy was x squared, that means this is my coefficient for x and this is my constant.
So now there's...
You see where I'm going with this? We found 2 zeros, so it went from a degree of 3 to a degree of 2 and then 1, right? How would you write this last guy right here? Isn't that just 3x minus 2? So my question to you is, when does that equal 0? What would you say?
2/3.
X equals 2/3. So what are the zeros that we found for this function?
Negative 2 plus 3i.
Okay.
2 minus 3i.
So your zeros, if we list them. Negative 2 plus 3i. Negative 2 minus 3i. 2/3.